Let's discuss this question next. Reduce 1 upon 1 minus 4i minus 2 upon 1 plus I times 3 minus 4i upon 5 plus I to the standard form. Okay, what is the standard form? For any complex number, the standard form is a plus ib form, right? For any complex number, the standard form is z equals a plus ib. Now, this is the form which is called standard form. So, for converting this complex number into that simplified form and the standard form, what we'll be doing is we'll have to first manipulate this whole thing and simplify this complex number. Let's try to simplify this complex number somehow. How do we go about doing this? Now, one of the approaches is to maybe take the LCM over here, but as you can clearly observe, this will complicate things a bit. Another approach which I have in mind is, why not simplify this denominator first, this particular term first, by multiplying with the complex conjugate of the denominator in numerator and denominator both. So let's try to simplify this. Let this whole thing is equal to z. This is 1 upon 1 minus 4i minus 2 over 1 plus I times 3 minus 4i over 5 plus I. These complex numbers in the denominator are creating troubles. Let's try to multiply with the complex conjugate of each term within that term only. Okay, with that term only. Let's try to multiply this. What I'll be getting is, this is 1 plus 4i in the numerator, 1 minus 4i in the denominator multiplied with 1 plus 4i in the denominator. This whole thing can be written as this. Yes. What I've simply done is I've multiplied with 1 plus 4i in the numerator and denominator. What else? This is 2. Let's multiply with 1 minus I, 1 plus I and 1 minus I over here as well. Okay. Once I do this, can I do a similar thing over here also? Yes, I can do a similar thing over here. This is 3 minus 4i, multiply it with 5 minus I, and let's multiply with 5 minus I in the denominator as well. Where did you get that 5 minus I from? It is the complex conjugate of 5 plus I, right? Therefore, I am multiplying with this. What does the simplify do? This is 1 plus 4i, which is okay. What is this? This is 1 square minus 4i square. 4 square I square, which is 16 times I square. 16 times I square would be actually minus of minus 16 plus 16. This will be a 17 in the denominator. Okay. Did we miss anything? No. This is 1 minus 4 square I square, right? 4 square is 16, I square is minus 1, so that will become 1 plus 16, which is 17. Minus 2 times 1 minus I is okay. What will this be? This will be 1 square minus I square, which is 1 minus minus 1, 1 plus 1, which is 2 in the denominator over here. This is what I'll be getting. Yes. Further, what about this whole expression? Let's try to observe this expression over here. What do we get? In the denominator, you get 5 square minus I square. 5 square is 25 minus of I square, which is minus minus 1. That will be plus 1. 25 plus 1 is 26 in the denominator. What about the numerator? We'll apply the distributive law and multiply 3 with a 5, that is 3 into 5, 15. Minus 3i, okay. Minus 4i into 5 will be minus 20i, and minus 4i into minus I, what will that be? Minus plus 4i square, sorry. Plus 4i square. This is what I'll be getting over here, right? Can we simplify this further? Yes. Okay, this is a 2. Let's cancel these 2's over here. And first, what I'll do is, can I take the LCM over here and between these? Yes. Let's take the LCM of 17 over here. And what do we get in the denominator is 17. This is 1 plus 4i and minus 17 times this would be minus 17 plus 17i. This is what I'm getting over here. Can you please note that? Yes. This minus goes inside the bracket, the second term becomes positive. Please note that carefully. Take care of the negative sign very carefully. What about this? This is 4i square, which becomes minus 4. 15 minus 4 is actually 11. Okay. And this minus 3 minus 20 becomes minus 23i upon 26. That's what I get in the denominator. As you can simply see, we have two complex numbers getting multiplied in the numerator, and in the denominator we have 17 times 26. We can handle that, right? So this converts to what? what I'm getting is 1 minus 17, which is minus 16, plus 17 plus 4 is 21i. Okay. And this gets multiplied with 11 minus 23i over 17 times 26. Right? I hope that's correct, yes. How do we do it? We simply multiply the numerator in there. Let's do it. So this first term, minus 16 will get multiplied with 11. What I'll be getting is minus 16 times 11. Okay. What else? This minus 16 gets multiplied with minus 23i. That will give me plus 16 times 23i. Okay. This 21i gets multiplied with 11. Let's multiply that. Plus 21 into 11i. What else? This 21i gets multiplied with minus 23i, and that will give me minus 21 times 23i square. What about the denominator? In the denominator you have a 17 into 26. Let's multiply that. Can you do it? Yes, obviously multiplication can be done very easily. This is 7, 6, 42, 2, and there's a 4 carry. 6, 7 to 14 is 20, 24. 4 is there and 2 carries. 2 into 1 is 2, 2 plus 2 is 4. This is a 442 in the denominator, right? Can you do a 2 by 2 multiplication very easily? Yes. In a single line? Oh, that is also possible, right? Let's multiply 16 into 11. Now this is simple. 176. This is minus 176. What about 16 times 23? Let's multiply it once again. 3 into 6 is 18. 1 carry. 3, 6 to 12, 13, 14, 15, 1, 6, 16. And then 1 carry. This is 368i. What else? 21 times 11. Now 21 times 11 is again simple. This is 231. 231i. What about the last one? 21 times 23. This is 22 plus 1, 22 minus 1. This is 22 square minus 1 square. 21 is basically 22 minus 1 and 23 is 22 plus 1. So I can multiply them together by converting them in the form a plus b, a minus b. That will be 22 square, which is 484, minus 1, 483. Now minus 483 I square. I square is also minus 1, right? So minus 483 into minus 1 will become plus 483. Denominator you have a 442, and let's add the real terms together, the imaginary terms together. What you get is 483 minus 176. 83 minus 76 is 7. 400 minus 4 minus 1 is 3. This is 307. And what else? What do you have over here is 599. 599i. Right? This is 599i upon 442 in the denominator. And is that all? Yes, that is all. Is it in the form a plus ib? We can write it in the form a plus ib by taking this 442 with each term, right? This 442 goes here and this 442 goes here. This is the final answer. This in the standard form is what we have done. 307 plus 599i upon 442. That's the complete solution of this question over here.